Hello, Namaste. Welcome you all in my video lecture series. Today we are going to talk about solution of partial differential equation PDE. So for today's video presentation, we have selected the semi-linear partial differential equation, and the method that we have selected here, that is a Lagrange method. So Lagrange method is used to solve quasi-linear partial differential equation, and the number of types that you can see variation in this Lagrange's method that you can see. So for today's we are going to talk about the type 1 solution, and in the sequence later on we will come with the type 2, 3, 4 type of solutions. This is Brijesh Kumar Jha, faculty of mathematics. So let's talk about the Lagrange's method. So first we see what is Lagrange method, how we apply. So once we talk about the general solution of such quasi-linear partial differential equation, so partial differential equation that is represented in the form of PP plus Q, QR, where capital P, capital Q and capital R are the function of X, Y and Z. So the solution of such partial differential equation can be defined in the form of phi u v is equals to 0, where u and v are the two solutions that we say obtained from the subsidiary or auxiliary equations. Phi is any arbitrary function, so always we define the solution in the form of phi uv, where u and v are obtained separately. So now let us talk about the solution of such auxiliary equations. So auxiliary equations are what that is obtained from the that given partial differential equation, and somehow it is also known as subsidiary equation. So auxiliary equation is what? It is dx upon capital P is equals to dy upon capital Q and is equals to dz upon capital R. So in type 1 that you will see such type of this auxiliary equation. In later type we will modify our auxiliary or subsidiary equations. So after defining this auxiliary equation, what we do, we select any two fraction. Let's say fraction 1, fraction 2 and fraction 3 are given. So any two fractions that you can select and solve. By solving this you will get the one type of solution, either u and v. So first solution that we solution of by selecting these two auxiliary equations, we get solution, it is u, and other selection that is v. So once you select these two fractions, your equation will be ordinary differential equations. So the solution of ordinary differential equation that we obtain in the form of uv. So any two combination you can perform here, either by selecting 1 and 2, 2 and 3 and 1 and 3. So total 3 solution or 3 ODE you can develop. First two is required to get the solution phi of uv. So now we can move for the question or example that we say. So in example 1, what we can see here, the coefficient of a small p that we identify as a capital P, this xz that we identify as a q, and y square that we identify as a r. So after identifying this capital P, Q, R, we go for the auxiliary equation. So always write the auxiliary equations. What we can get, dx upon capital P is equals to dy upon capital Q is equals to dz upon capital R. Now we put the value of P, Q, R here. So it is dx upon y square z by x and is equals to dy upon xz is equals to dz upon y square that we get. Now our part is to find the u and v. To get the value of u and v, or to find the u and v, what we do here, we take any two fraction. So for example, if we take here first two fraction, so purpose of having this two fraction is what? To formulate the differential equation. It will not remain the partial differential equation. So by taking first two, what we get, dx upon y square z by x and dy by xz. So what happens, these two z will be cancelled here. This x you can put here. This x will also go there, so it will be x square dx, and it will be y square dy. So by simplifying and integrating, what we get, it is x cube by 3 minus y cube by 3 is equals to some constant. So what we have, x cube by 3 minus y cube by 3 is equals to, let's say, any c constant that we say. So by taking 3 common, 3c is equals to c1 that we have taken here. So first solution of this differential equation is what, u of x, y, z that we have obtained as a c1. Now come to the next, any two fraction that you can select here. So you can check here the auxiliary equations. So auxiliary equation, what we can have, taking the first and last fraction. If feasible, you can take second and last as well. So the first and last fraction here, what we can see, it is dx upon y square z upon x and dz upon y square. Again simplify here, so y square will be cancelled, x that will be goes to the numerator, and z is going to be here. So what we get, x dx is equals to z dz. Again by integrating, what we get, x square by 2 minus z square by 2 is equals to some constant c a, let's say. So by taking 2 as a LCM, 2a is equals to c2 that we can write. So second component of the solution, that is vxyz is equals to c2 that we obtain here. So our required solution of the given problem is what, phi x cube minus y cube x square minus z square is equals to 0. Phi definitely is a arbitrary function here. So in this way we can get the solution of this linear partial differential equation. Now come to the next here, come to the next example. P tan x plus Q tan y is equals to tan z. So again first we identify the capital P, capital Q and capital R. Now the subsidiary or auxiliary equation that we can write here, dx upon tan x is equals to dy upon tan y is equals to dz upon tan z. First two fraction we can take here. So by taking first two fraction, what we get, it is cot x dx and it is cot y dy, or cot x dx minus cot y dy that we get. So by integrating, so cot x dx is roughly I can show you, otherwise you can revise your integration. If you have problem in the integration, you can revise. So by integrating, it is cot x dx, it will be what, integration of cos x upon sin x dx. So you can select sin x is equals to t. So what we get here, cos x dx is equals to dt. So your whole integral will be what, integration of 1 upon t dt. So it is going to be log t and plus some constant that we can write. So t is what, it is sin x. So our final form is what, log of sin x. Similarly cot y dy will be log of sin y that you can have. So by integrating, what we get, log sin x minus log sin y is equals to log c1, and finally sin x upon sin y is equals to c1. The first component of phi, that u is equals to c1, u x yz is equals to c1 that we obtained here. So in this auxiliary equation, any two fraction that you can take. So we required only two. First already we have discussed. Now we talk about the second. So last two fractions we have selected. So it will be cot y dy is equals to cot z dz. So by integrating, again it will be log sin y minus log sin z is equals to log c2, or sin y upon sin z is equals to c2 that we get the second component b. So the required solution that we obtained for the given question, that is phi of sin x upon sin y upon sin z is equals to 0. You can select other also, sin y upon sin z, sin x upon sin z is also possible. So number of solution can be found here. and phi is arbitrary function is here. Now come to the next question. Y square p minus xy q is equals to xz minus 2y. So the subsidiary equation that we can represent, so as we know, first identify the PQR. So it is P, this is Q, Q is equals to minus of XY, and this is your R. So the auxiliary equation that we can write, dx upon y square is equals to dy upon minus xy, and dz is equals to that R we have written here. Now the next part is select any two fraction. So in the first part we take here first two terms. So one y will be cancelled here. So it is dx upon y is equals to dy upon minus x, or by simplifying we can write x dx plus y dy. Now by integration it is x square plus y square is equals to c1. Again 2 we have taken common, that we have taken earlier also in the previous examples. So the u component is that we have got here. Now what we can do here, we can see the x will be cancelled, it will be the function of y and z only. So the last two term we can consider here, dy upon y, because x is cancelled here, and dz upon z minus 2y. Now simplify here, dy multiply by z minus 2y and minus y multiply by dz. So it is z dy plus y dz minus 2y dy. This z dy into y dz, that we can write d of yz. So d of yz minus 2y dy is 0. So by integrating, what we get, yz minus y square is equals to c square. Now after getting these two solutions, what we have, x square plus f of x square plus y square, yz minus y square, that is the required solution. Come to the last question. This is today's last question. So fourth question that we are getting here, capital P is x squared, capital Q is y squared, and capital R is z squared. So very quick, we can have the subsidiary or auxiliary equation. So it is dx upon x square, dy upon y square, and dz upon z square. Any two fraction that we can take here. Suppose we take first two fractions. So what we get, dx upon x square is equals to dy upon y square. Now integrating, what we get, 1 upon x minus 1 upon y is equals to c1. The next part is you can select again other two. So either two, last two, or first and third that you can take. So here we have taken the last two terms. Last two terms is what, dy upon y square is equals to dz upon z square. In the same manner we can integrate here. So it is 1 upon y minus 1 upon z is equals to c2. So as we obtain these two factor u and v of phi, so our solution, final solution is what, f is equals to 1 upon x minus 1 upon y, 1 upon y minus 1 upon z. Other than this also you can write 1 upon x minus 1 upon y, 1 upon x minus 1 upon z. Here the first and second that we have selected, here second and third we have selected, and here first and third fraction we have selected. So in this way we can obtain the result of such quasi-linear partial differential equation. Hope so it is clear the concept of using Lagrange method type 1 to solve the partial differential equation. So you can comment on the comment box. If you have any query, definitely you can like, subscribe our channel for more updated videos, as I will upload the other problem also, type 2, 3, 4 Lagrange methods, and other mathematical content as well. So thank you for watching this video. The upcoming if it is what, type 2 Lagrange's method. Thank you once again.